Welcome back. Today we are going to discuss examples on Gauss-Jordan elimination method of solving a system of linear equation. Let us begin with this example. Using elementary row operation, solve the system of equation given. The method that we are going to adopt is known as Gauss-Jordan elimination method. Refer the process we have discussed in the slides that we have shared during the last class. So let's begin the solution of this. Solution. We first write the coefficient matrix here. Here, the coefficient matrix is 1, 1, 1. All the coefficient in the first equation is 1, 1, 1. Then second equation coefficients are 1, minus 1, 2. So it's 1, minus 1, 2. And third equation coefficients are 3, 1, 1. 3, 1, 1. Here x is equal to the variable matrix is x1, x2, x3. And B matrix is the right hand side members of the equation. So it is 6, 5, 8. We begin with the augmented matrix and reduce it to row echelon form. The augmented matrix is so what is it? It is A and augmented the column of B with it. So the matrix is 1, 1, 1, 6, 1, minus 1, 2, 3, 1, 1. So this is matrix A, and then augment the last column as the column in B. So it is 6, 5, 8. So you can put one partition if you want, but it is not necessary. Just to remind you that the first column is for the matrix B. So we will now reduce it to row echelon form. So first non-zero column is the first column itself, and topmost entry is non-zero. So this is my first pivot entry. So the row operation I'm going to apply are, I have to make this entry 0, this entry 0. So R2 goes to R2 minus R1, because 1 minus 1 will make it 0. And R3 goes to R3 minus, so 3 minus 3 into 1 will make it 0. So R3 minus 3 into R1. So my matrix will reduce to, after this operation, first row I am not changing, so it will remain same. Second row will be 1 minus 1, 0, minus 1 minus 1, minus 2, 2 minus 1, 1, 5 minus 6, minus 1. Then 3 minus 3, 0, 1 minus 3, minus 2, 1 minus 3, minus 2, 8 minus 18, minus 10. So my first pivot that we have decided is this one. Now we are going to concentrate, as we have discussed, we are going to concentrate on this portion of the matrix and decide which is our next pivot. So in this portion, this is going to be my next pivot. So if this is pivot, I have to reduce this entry to 0. So I will apply the operation R3 goes to R3 minus R2, because minus 2 minus minus 2 makes it 0. And the reduced matrix is, 1, 1, 1, 6, 0, minus 2, 1, minus 1, then 0, 0, minus 3, minus 9. So this is my first pivot, this is my second pivot, and you see that this is going to be the third pivot. So every row got its pivots, so which is in row echelon form. So you got the row echelon form of the matrix. Now what to do? Now row echelon form of the matrix AB is 1, 1, 6, 1, 6, then 0, minus 2, 1, minus 1, then 0, 0, minus 3, minus 9. So this is first pivot, second pivot, third pivot. So we don't have any 0 row here. Therefore, rank of the augmented matrix is equal to 3, number of non-zero rows here. Also, row echelon form of the matrix A is, remember, the first 3 columns of this matrix are nothing but due to the matrix A. So the first 3 columns of this row echelon form will give you the row echelon form of A. We have already discussed examples on this. So row echelon form of A is 1, 1, 1, then 0, minus 2, 1. So you just leave out the last column here, then 0, 0, minus 3. Okay. How many non-zero rows here? All rows are non-zero. So therefore rank of A is equal to number of non-zero rows 3. Since rank of AB, now recall the theorem, rank of AB is equal to rank of A is equal to 3 is equal to number of unknowns. Therefore, the system, so under this condition, the system has an unique solution. Unique solution. Okay, unique solution. So now what is the solution? Let us find the solution now. So what we are going to do to get the solution, so how to write down the solution? To find the solution, we are again going back to the row echelon form of the augmented matrix. So this is the row echelon form of the augmented matrix. So we will use this row echelon form to get the solution. So if you look at the last row here, it is minus 3, minus 9. So I will use this using R3, we get, so if I rewrite the equation using R3, so coordinate of coefficient of x1 is 0, x2 is 0, but coefficient of x3 is minus 3, so it is minus 3x3 is equal to minus 9, and this implies that x3 is equal to 3. Now using R2 we get, now what is there in R2? Coefficient of x1 is 0, x2 is minus 2, and x3 is 1. So I will write minus 2x2 plus x3 is equal to minus 1. So this implies, I know x3 already, it is 3. So put 3 here and calculate x2. x2 will be 3. So x2 will be 2. So again I'm explaining. So using R3 you get minus 3x3 minus 9 equal to minus 3x3 minus 9, and this implies x3 is equal to 3. Then using second row, which is minus 2 1 minus 1, coefficient of x1 is 0, so it is minus 2x2 plus x3 minus 2x2 plus x3 equal to minus 1. So that gives you x2 equal to 2, because x3 we have already evaluated. Now we will use the first row. First row is x1 plus x2 plus x3 equal to 6. So using R1 we get, using R1 we are going to get what? So R1 is 1116. So it is x1 plus x2 plus x3 is equal to 3. So this implies x1 is equal to, we have already noted what is x2, x3. So x1 is equal to, sorry, this is 6 not 5. So x1 is equal to 1. So therefore the required solution is x1 is equal to 1, x2 is equal to 2, and x3 is equal to